Hi Ma'am Cañete, my name is Maclentes Layasan and this is my virtual presentation. So number one, explain that faults are often but not always found near plate boundaries and that each type of faults are frequently associated with specific types of plate movements. However, you can probably find all types of fault movements associated with each type of plate boundary. This is my answer for number 1. Faults are fractures in earth crust where rocks on either side of the crack have slid past each other. The faults are often but it is not always because not all faults intersect Earth's surface and most earthquakes do not rupture the surface. When fault does intersect the surface, object may be offset or ground may crack or raised or lowered. We call a rupture of the surface by fault scrap, and identifying scraps in an important task of assessing the seismic hazard in any region. When an earthquake occurs, only a part of fault is involved in the rupture. That area is usually outlined by the distribution of aftershocks in the sequence. We call the point or region where an earthquake rupture initiates the hypocenter or focus. The point on Earth's surface directly above the hypocenter is called epicenter. Next is normal faults are often associated with divergent tensional boundaries. Next is thrust faults are often associated with convergent comprehensial boundaries. And next is strike slip faults are often associated with transform or sliding boundaries. So my answer, apart from the meteor impacts, tsunami are caused by sudden vertical movements of the sea floor. The movement can be detected as earthquakes associated with activity on reverse or normal faults or earthquakes associated with volcanic eruption or submarine land and slides. Reverse faults occur at convergent plate boundaries, while normal faults occur at divergent plate boundaries. Earthquakes along strike slip faults at transform plate boundaries generally do not cause tsunami because there little or no vertical movement. All three types of plate boundaries can be found around the edges of the Caribbean plate. Although the divergent type of boundary is restricted to a very small region west of Jamaica, just south of the Cayman Islands, near the eastern margin of Caribbean plate there are recently active volcanoes in Lesser Antilles. These are associated with convergent plate boundary and caused by subduction of the North American plate beneath the eastern edge of the Caribbean plate. Faults are often found along divergent plate boundaries, such as under the ocean where new crust is forming. In the field of geology, a normal fault is a type of deep slip fault where the hanging walls moves downwards from the footwall. The average dipping angle of normal faults ranges from 45 to 90 degrees. So normal faults are the opposite of reverse faults. When we tackle about thrust faults, thrust fault is a type of reverse fault that has dip of 45 degrees or less. If the angle of the fault plane is lower, often less than 15 degrees from the horizontal, and the displacement of the overlying block is large, often in the kilometer range, the fault is called an overthrust or overthrust fault. Reverse deep slip faults result from horizontal compressional force caused by shortening or constructing of earth crust. The hanging wall moves up and over the foot wall. Thrust faults are reverse faults and deep less than 45 degree. In the strike faults, the motion along transform plate boundaries typically occurs along major transform faults, which on continents are commonly referred to as strike-slip faults. Strike-slip faults, also called transcurrent fault, wrench fault, or lateral fault. In geology, a fracture in the rock of Earth's crust in which the rock masses slip past one another parallel to the strike. The intersection of a rock surface with the surface or another horizontal plane. These faults are caused by horizontal compression, but they release their energy by rock displacement in a horizontal direction almost parallel to the compressional force. The fault motion of a strike-slip fault is caused by shearing forces. If the block on the far side of the fault moves to the left, as shown in this animation, the fault is called left lateral. Number 2. Ask these following questions. What kind of faults would you expect to find in the Himalayas mountains, and why? The faults that I would expect to find in Himalayas is the reverse faults. It also called thrust faults. Slide one block of thrust on top of another. These faults are commonly found in collision zones, where tectonic plates push up mountain ranges such as the Himalayas and the Rocky Mountains. And let's proceed for second question, that what kind of faults would you expect to find along the Mid-Atlantic Ridge? So the segments of the Mid-Atlantic Ridge are offset by some long transform faults. Most of the earthquakes are located along transform faults, rather than along the spreading segments, although there are clusters of earthquakes at some of the ridge transform boundaries. So the third question is, what kind of fault is the San Andreas Fault? So the fault that in the San Andreas Fault is the strike-slip fault, because it is a fault on which the two blocks slide past one another. The San Andreas Fault is an example of a right lateral fault. Is the California likely to fall off into the Pacific Ocean, and why? California cannot fall off or sink into the ocean during the next large earthquakes. The fault moves horizontally much more than vertical, and Western California is part of the Pacific Plate, so it can fall off into the Pacific Ocean. Not all faults are associated with plate boundaries. Plate boundaries are always fault, but not all faults are plate boundaries. The movement of the plate relative to each other distorts the crust in the region of the boundaries, creating system of the earthquake faults. There are also major faults and the system of faults in the interiors of. So let's proceed to another question. Explain that there is a broad range of faults based on type, linear extension, displacement, age, current of historical activity, and location on continental or oceanic crust. Have students research example of non-plate boundaries fault. So driven by plate tectonic forces, associated mantle convention influencing the rigid lithosphere. Fault systems are often associated with volcanic regions. Faults may form and remain active for long ages from becoming inactive, and then may become reactive again. In some later period, tectonic forces within the earth deform rock through the process of folding the faulting and faulting, producing many of the landscape features observable around us. So the example of non-plate boundary fault is the subduction zone, because subduction zone is not a type of plate boundary. Let's proceed to another question. So explain to the students that the stresses and strains in the Earth's upper layers are induced by many causes: thermal expansions and contraction, gravitational forces, solid earth tidal forces, specific volume changes because of mineral phases transition, and etc. And faulting is one of the various manners of mechanical adjustment or release of such stress and strain. So, stress and strain in the Earth's upper layer are induced by many causes such as a thermal expansion and contraction or gravitational forces. In addition to movement of the Earth's tectonic plates, stress is the force applied to an object. In geology, stress is the force per unit area that is placed on a rock. Faulting is one of the various manners of mechanical adjustment or release of such stress and strain. When stress causes a material to change shape, it has undergone strain or deformation. Deformed rocks are common in geologically active areas. And let's proceed to coloring K. The color of rock layer X is green, and the color of rock layer Y is yellow, and the color of rock layer Z is red. So the color of the river is blue, and the road is black. The railroad tracks is brown, and the grass is green. So this is my coloring K. So the color of the grass, and this is the grass. The grass is green, and the railroad tracks is brown, and the rock layer X is green, and the rock layer Y is yellow, and the rock layer Z is red, and the river color is blue, and then the road is black. And that's all. Thank you.